Fruit-only diets, sometimes referred to as frugivorous or extreme fruit-based eating patterns, have gained attention for their simplicity, high vitamin and antioxidant content, and emphasis on whole, minimally processed plant foods. Fruits are naturally rich in fiber, water, vitamins, minerals, and polyphenol, and they offer numerous health benefits, including enhanced satiety, improved gut health, and antioxidant protection. However, emerging research suggests that diets composed exclusively or predominantly of fruit, particularly when sustained over the long term, may place stress on the liver due to chronically high intake of fructose, the naturally occurring sugar in fruit. While these findings may sound alarming at first, a careful analysis reveals both the physiological mechanisms at play and the ways in which the positive aspects of fruit consumption can be preserved while mitigating potential risks, offering a balanced perspective on diet design and metabolic health. At the center of concerns about fruit-only diets is fructose metabolism. Unlike glucose, which is metabolized widely in peripheral tissues, fructose is primarily processed in the liver. In moderate amounts, fructose contributes to energy metabolism without causing harm, particularly when accompanied by fiber and other nutrients that slow absorption and modulate metabolic responses. However, chronically high fructose intake, especially in diets that are almost exclusively fruit, can overwhelm hepatic metabolic pathways. The liver converts excess fructose into glucose, lactate, and fatty acids. When the capacity to handle this load is exceeded, triglycerides can accumulate within liver cells, a process known as hepatic steatosis or fatty liver. This accumulation can trigger mild metabolic stress, inflammation, and, in some cases, elevations in liver enzymes such as ALT and AST, which are markers of liver function. These effects do not imply that fruit is inherently harmful. Rather, they highlight the importance of dietary balance, portion control, and nutrient diversity in supporting optimal liver metabolism. Beyond fat accumulation, high fructose intake from fruit-only diets can influence insulin and glucose regulation. While the fiber in whole fruits helps to blunt postprandial glucose spikes, extreme consumption can still result in high total sugar loads that require the liver to process substantial amounts of carbohydrates. The liver responds by increasing de novo lipogenesis, the production of new fat from carbohydrates, which, over time, can contribute to metabolic stress. Despite these potential risks, it is important to recognize that the body's adaptive mechanisms are remarkably resilient. For most people, moderate fruit intake integrated into a varied diet supports glycemic control, satiety, and cardiovascular health, illustrating that the negative effects observed in fruit-only patterns are primarily a consequence of extreme, unbalanced consumption rather than the inherent qualities of fruit itself. Another consideration is nutrient balance. Fruit-only diets can provide high levels of vitamin C, A, potassium, folate, and a wide array of antioxidants, all of which support liver health, reduce oxidative stress, and improve immune function. The challenge arises because other nutrients essential for liver function, such as adequate protein, choline, and certain fats, may be insufficient in an exclusively fruit-based diet. Protein is particularly important for maintaining hepatic enzyme function and supporting the liver's detoxification pathways, while healthy fats provide structural components for cell membranes and facilitate the absorption of fat-soluble vitamins. In this sense, the potential for liver stress reflects a nutrient imbalance rather than an inherent flaw in fruit consumption, highlighting an opportunity to design diets that harness the health-promoting properties of fruit while supplementing with complementary sources of protein, fats, and micronutrients to protect liver function. The gut-liver axis also plays a role in mediating the effects of high fructose intake. The fiber in fruit supports a healthy microbiome and promotes the production of short-chain fatty acids, SCFAs, which have anti-inflammatory effects and support liver metabolism. However, an exclusively fruit-based diet may still deliver very high amounts of fermentable sugars that alter gut microbial balance, potentially increasing intestinal permeability and systemic inflammation. This, in turn, can exacerbate hepatic metabolic stress. Again, the positive angle is that introducing dietary variety, legumes, vegetables, nuts, seeds, and whole grains can enhance microbial diversity, stabilize fermentation patterns, and reduce potential liver stress, demonstrating the adaptability of the gut-liver axis to diet composition. Physical activity and energy balance also interact with the metabolic effects of fruit-only diets. Excess caloric intake from high fructose consumption, if combined with sedentary behavior, can further increase liver fat accumulation. Conversely, regular physical activity enhances hepatic fatty acid oxidation, improves insulin sensitivity, and reduces overall metabolic stress. This suggests that the impact of high fructose diets is not fixed, but can be moderated by lifestyle factors, providing a practical pathway to mitigate risk while still enjoying the benefits of fruit as a nutrient-dense, antioxidant-rich food group. An encouraging perspective comes from the broader body of evidence on fruit consumption. Moderate fruit intake, typically 2 to 5 servings per day, has been repeatedly associated with reduced risk of chronic diseases, including cardiovascular disease, type 2 diabetes, and certain cancers, as well as improved gut health and satiety. These benefits stem from the synergistic effects of fiber, polyphenol, micronutrients, and phytonutrients. The adverse outcomes observed in fruit-only diets are primarily a consequence of extreme patterns, rather than moderate or balanced consumption. In other words, the research highlights the importance of dietary variety rather than discouraging fruit altogether, illustrating how positive health effects can be maximized when fruit is combined with other nutrient-rich foods that provide protein, healthy fats, and complex carbohydrates. In conclusion, new evidence suggesting that fruit-only diets may impair liver function underscores the physiological realities of fructose metabolism and the limits of the liver's capacity to process extremely high sugar loads. Excessive fructose intake can contribute to hepatic fat accumulation, mild metabolic stress, and transient changes in liver enzymes, particularly when protein and fat intake are insufficient. However, these findings do not diminish the many health benefits of fruit itself. By integrating fruit into a balanced, diverse diet with adequate protein, healthy fats, and a variety of other plant-based foods, individuals can enjoy the antioxidant, fiber, and micronutrient advantages of fruit while supporting optimal liver function, metabolic resilience, and long-term health. The key takeaway is that dietary extremes can pose challenges, but thoughtful, balanced nutrition allows the liver to thrive while maximizing the remarkable health-promoting properties of fruit.